Dr. Christine Jones, the soil carbon lady, you'll hear her say that a million times. Professor Walter Yaney, the guy who talks about the water cycle, etc., he talks about that. I talk about that. I want country to stay green for as long as possible. And this is not just trees. The trees are going to be part of our landscape. I'm not having a go at trees here. What I'm having a go at is the forest or woodland type communities. And we'll be able to define the two quite nicely separate in a little bit later on. So what we're trying to do to build those soils is to maximize the root exudates. Why? So a grassland or a grazing ecosystem is a better term for it because you're always going to have dicotyledonous plants. In other words, plants with two leaves when they come out of the ground. They're the ancient plant systems. The first plants that there ever were came out of the ground with two leaves. A tree comes out of the ground with two leaves. They're ancient. Grasses are the highest order plant family on earth. What do I mean by highest order? They are the most recently evolved. In other words, the world has evolved from trees and shrubs to savannas and grasslands and mixed grazing ecosystems. I'm leaving my cage. Occasionally I've been told this is my cage I must stay in. So we've got to try and keep this in our minds when we're doing this, because grasses are the highest order plants. So they where evolution was going to. And every one of you sitting here should be so thankful that that's the case. You are in this room now in what we call civilization. It doesn't mean we behave any better than our forefathers, but maybe what it means is we're able to live in bigger and bigger mobs of humans is what civilization means. So when we look at it that way, we're able to do that because we were able to leave the forests and go out into the savannas where the animals were there for us to graze. If we'd stayed in the forests, or the world had stayed as forests, we would still be swinging from tree to tree and not even discovered a loincloth or a freaking apple, so we couldn't get up to business. So now you think about it that way, it's a pretty much an evolutionary process allowing the world to develop to grazing animals that allowed us to get out from the forests that put our civilizations together and begin to develop ourselves. So this critical thing here is, for me, is about how we run that. So the later part of my sessions in the paddock will be, how do I get you to run this so that you can have these dense plant bases, how you can keep it greener for longer, how to do the opposite of what most people are going to teach you in a grazing school. So these plants produce sugars, they go into the soil, there's rhizosphere with sticky root exudates. Those bacteria and single-cell fungi love those sugars. They eat them. They have a lifespan of about 4 hours. So they get onto this little rhizosphere. They live on the edge of that. They get it born. Within 4 hours, they've had a leg over, had children, and died. And when they die with their heads in the feed bunker. So those organisms are then pushed out by the living ones. The dead ones are pushed out. The necromass of them, the dead organisms, basically are then taken and put together and into these humic compounds underground. And it's those humic compounds, the hexagonal humic compounds, which are ionized. In other words, the positives and the negative charges are made available to them. They actually hold each other together and apart, and that's where the soil structure comes from. So it happens underground, not above the ground, not above the surface. So the soil temperature there is managed by that evapotranspiration, the transpiration through the plant. Now I've got this word here, saprotrophs. In those ancient systems that were put together in the woodland days, saprotroph was a group of fungi, which you'll see pictures of in a minute, but we'll talk about them. But when they've evolved into the grazing ecosystem scenario, those saprotrophs have become invisible and they've become endophytes. So this is a little root system we've dug out of that plant, out of that soil there. You can just look at every single root in there. You're not actually able to even see the roots. What you're looking at is the sugars sticking soil to the roots. Can you see that in that picture? So what's happening there is we're pumping sugars out of that root system that's feeding those organisms around it. That is happening under the ground. So when you think about a fungi that's supposed to do the breakdown of the plant material in there, there is no food source for it. Because the animal's eaten 90% of the plant material off above ground. These plants are not producing litter for the soil surface, they're producing sugars for organisms to eat underground. It's the bodies that fall out of that create that structure. And when you think of it from this perspective, suddenly that fungi that used to do the decomposition loses its job. What do things do when they lose their job? They adapt to find new jobs. So those saprotrophs that used to be acid producers breaking down plant material shifted and became endophytes and work inside the root system now. So its mycelium, the end of each of its little spider's web sticking out, goes right through into the endocrine system of each cell that's in that root system. That passes nutrient, moisture, and minerals around. It's that system which is able then to have the communication occur between plants in that soil. That's what I want your plants in your soil to look like. And this picture happens to be a grass, I think. I can't see it, but it looks like a grass. That next one there is a grass as well. That one is a little sedge, which is a bulbous plant that's doing that, but you can see the sugars pouring out the bottom of that into that soil system there. There's two grass plants here next to each other, the one from just outside the fence in the road reserve and the other one inside the paddock. Which one of those two grasses is from inside the paddock? It's a set stock paddock and a road reserve. And in that road reserve, there's occasional stock going down the stock route. Which plant is in the road reserve and which one's in the paddock?
The left one's in the paddock.
The left one's in the paddock. Other money going the other way?
The right one's in the paddock.
The right one's in the paddock. You see how fucked up our Australians have become? Huh? We just get hammered by all this different information. Righto, should we send the pot around? We should send the head around. Who's going to put money on which one of these two options? Yeah? Which one? You've all been to these grazing schools. Little plants, little root systems. Big plants, big root systems. You've been to that school, haven't you? Take your notes you got from that and make a fucking barbecue out of it. That plant with the big root system on your left is the one from inside the paddock. It's been set, stocked, and you got it right. Some of you guys, well done. It's been grazed, grazed again, grazed again, grazed again, grazed again. It has evolved to be grazed. That is its sole job on earth, is to catch sunlight, put carbon, water, oxygen, so hydrogen, oxygen, carbon together to create cellulose. What does it produce the cellulose for? Not to make skin bumpy. No, it is there for an animal to eat. That is what it's for. And what is it going to be made available to the animal for? To be turned into dung and urine and the byproduct into growth and children. Where does money come from for your cattle enterprise? You all stuck your hand up about cattle. Where does the money come from? Growth, children. Growth, children. Calf, brand, wean. That's what it's about, isn't it? Brand, wean, truck away. That's making money. That's what it's for. And what's happening underground, because that plant's being grazed, that plant is pushing the sugars out. Look at the roots sticking all that soil to it underground. It's pumping the sugars out under the ground, which is then feeding the biology that lives along that root system. Again, food source, and it's just pumping out there for them to do. Die with their head in the feed bunker, get pushed out the way, get turned into humic compounds, deeper and deeper and deeper under the ground. So, little plant above ground, big root system underneath. Big plant up on top, relatively small root systems underneath. Get that one out of your systems. Okay. Now, no, radio. This is quite fun. There's another soil that's really operating. So I've dug it out this deep, and I've broken it in half so you can see it. Do you see how much space there is in that soil? We're looking at the underground bit. I couldn't get my hand in the top of it, but by golly, I can get my fingers through the underground part of it. I can get my fingers through the underground part of it. I remember as a little kid,